Hello everyone. In this lecture, you'll be learning about what is stacks. So the outcome of the lecture will be you'll be knowing what is stack, the ways it can be implemented, and the fundamental operation that can be performed using stacks. Stack is nothing but a linear data structure which is similar to your array and your linked list, but here it is going to follow a certain principle for doing the operation. So the principle is last in, first out. It means that the last inserted element will be deleted first. So in this image, you can see that 3 elements are going to be inserted. So pink is the first element that is inserted, then green, and the last inserted element is your yellow. So while deleting your elements, the last inserted element, which is yellow, is deleted first, and then green, and then pink. So this principle or this concept is called as your last in, first out. And then second image, you can see that this is how your stack will be, and this is how push and pop operation is going to happen. Only one end of the stack is going to be used for doing the push and pop operation. So that one end will be pointed using the pointer called top. So top is a pointer we are going to use in a stack for doing push and pop operation. So when you are going to doing a stack operation, you'll be implementing a stack. So while doing that, you're going to initialize your top value as -1. So whenever you're going to implement a stack, the pointed top will be initialized as -1, which means that your stack is empty currently. So the first time you're implementing, of course, your stack will be empty. So that is represented using top as -1. So stack can be implemented using two ways. One is your array based and your linked list based. The first image represents how a stack can be implemented using array. And the second is how your stack is implemented using your linked list. So now we'll see how the fundamental operation that can be performed using your stack. So the first operation is push. Push is nothing but you're going to insert a new element into your stack. So this is how the operation happens. So in the first image, you can see that this is an empty stack. So if this stack is empty now, that means your top value is -1. So the second time, if I want to insert an element into my stack, then first thing I will be doing is I'll be incrementing my top value by 1. So initially, if the empty stack, my top will be -1. So during the push operation, I'm going to increment my top value as 1. So in this case, the -1 is incremented to 0. So at the 0th index of the stack, we'll be inserting the element 1. So this is array-based implementation of your stack. So array-based, your index value starts with 0. So at the top 0 now, it is going to point the 0th index, and the 0th index, your element 1 is inserted. So at the next push operation, again, I'm going to increment my top value by 1. That is 0 is incremented to 1. And it is going to point the first index. There I'm going to insert my element 2. So this is how the push operation happens. And we'll be seeing the routine in the upcoming slide. And the one thing before doing your push operation is you have to check a condition whether your stack is full or not. That means that if my stack is full or it is having some memory to insert a new element. So that condition will be called as overflow. So is full, we have to check is full. It means that you're going to check whether my top value is equal to array size -1. That means, for example, take an array size of 5. Array size 5 now, your index value will be 4. So array value index starts with 0. So the maximum index value of array size of 5 is 4. So if the top is equal to array size -1 now, it means that your stack is overflow. Overflow is a condition is that I'm trying to insert an element, but my stack is full. So that condition or that case is called as overflow. At the case of overflow, you can't insert any more element into your stack. So before going to the push operation, you're going to check for the is full condition, and you're going to do the operation, push operation. So next fundamental operation is your pop. Pop is nothing but I'm going to delete an element from my stack. As similar to your array and linked list, here we can't randomly pick an element and delete it. But in your stack, only the topmost element of your stack will be popped out. Popped out in sense it is going to be deleted. So I'm having A to E alphabets here. I can't randomly select C and delete here. If I want to delete C, I want to delete E, D, and then C. So only the topmost element of my stack will be deleted when you're calling the pop function. So as you check the overflow condition for push operation, here we'll be seeing checking my underflow condition, which means that if my stack is empty, I can't pop any element. It means that without having element, I can't delete any element. So before deleting an element, you'll be checking for the underflow condition. That is your is empty. How to check is empty? The first thing is whenever you're going to initialize your top value as -1, which is going to represent that your stack is empty. So if the top is equal to -1, it means that your stack is empty and you can't do the pop operation. If it is not, you're going to call the pop function so that the topmost element will be deleted from the stack. So we'll see the routine for your push operation. So consider the first image, which is a empty stack. That is my top is initialized to -1. So now I want to do a push operation. So I'm calling push 10, S, which means that I want to perform push operation. 10 is the element to be inserted in the stack name S. So this is the stack name S. In there, I'm going to insert an element 10. So initially, my top value is -1. So before that, I'm going to check a condition is full. That is, I'm checking whether my stack is full or it is having memory to insert a new element. If it is not, here we are checking the condition that it is not. It means that it is having space for inserting the new element. So the next one is, the first thing before doing a push is I'm going to increment my top value by 1. So this -1 will be incremented by 1 and becomes 0. -1 is incremented by 1 and it becomes 0 here. So at the index 0, my top pointer will be pointing. So this statement says that top is equal to top plus 1. I'm incrementing -1 to 0. And the next line is stack of top is equal to element. So this is top now. So stack of top is this index that I'm going to insert my element 10. And then if my stack is full now, I'll be printing that stack is full or stack overflow. So this is how your push routine goes. And pop operation, the routine of pop operation is, first I'm going to check whether my stack is empty or it is having elements. So the first condition is if top equal to -1, which means that your stack is empty or your stack is underflow. So if you're going to print stack underflow and leave, and if it is not, it is having element now, the first thing you're going to do is you're going to declare a variable and you're going to assign S of top. So in this image, you can see that it's going to have 5 elements. So 50 is the topmost element that is inserted in your stack at the index of 4. Currently, my top is pointing to the index 4. So I'm going to store this element in your X, and then I'm going to decrement my top value by 1. As we incremented for your push operation, in your pop, you'll be decrementing the top by 1. So in the second image, you can see that the top value is decremented from index 4 to index 3. So finally, you can return the X to know which element is deleted from the stack. And the next or final fundamental operation of your stack is your peak operation. Peak operation is nothing but it is going to return the topmost element or the last inserted element of your stack. It is similar to pop. We are going to check the is empty condition here. So if it is top equal to -1, it means the stack is empty and I can't return any element. So I'll be printing stack underflow. If it is not, it is having some element now, I'm going to return the S top, that is the topmost element. Here 50 will be returned. The difference between your pop and peak is pop, you're going to remove the element, but in your peak, it is just going to return the last inserted element and it is not going to remove the element. So that's all about the stacks.